Mathletes, it's chapter 3, sections E and F, factorizing quadratics. Okay, remember a quadratic trinomial is an algebraic expression that follows of the form ax squared plus bx plus c. A is your term with your x squared, b is your term with your x, and c is your constant. Okay, so remember that most of these are coming from the expansion of two binomials. When you expand binomials, we remember we got to multiply all of them through, and we end up getting these terms. Okay, so from that we recognize that the middle two terms are similar. They both have an x, so we add those coefficients up. They sum, they're there, and you get 7. And then also, this last constant term always comes from the product of our last two terms. Okay? So what we're going to do with factorization is we're going to be looking at these quadratics and going backwards. Okay? Remember, factorization is the inverse operation of distribution. So it's not always so straightforward, but how I'm going to help you try and get you to organize your thoughts is using a diamond method. Okay, so this diamond method is just a tool to help you organize your thoughts. Okay, so in the diamond, I am always going to say put the products of A times C. The A and C are coming from A, right, is your constant or the coefficient of your x squared term, and c is the constant. So multiply those together. Okay, and then for down here you're going to put your b term. Okay, so your b term being that term. Okay, the coefficient from upon your x. So what that will look like, for instance, if we are being asked to factor something like x squared plus 7x plus 10. Well, for this one, we have an a value of 1. Okay, we have a b value of 7. Okay, and we have a c value of 10. So if we insert a times c, that's 10, and our b value is here. So as this is saying, a and b are two numbers whose sum is p, okay, and whose product is q. So what we want to do is make sure we find two numbers whose product is 10 and sum to 7. So the factors are of 10 are 1 and 10. Well, you can't get to 7 there. The other ones are 2 and 5. So when you look at 2 and 5, their product is 10, and they add to 7. So from that, we're going to use these two terms to rewrite our middle term, our b term. So we'd write x squared plus 2x plus 5x plus 10. Okay? And from that, we are going to look just at our first two terms, factor out what they have in common. Well, they both have an x in common. I'm going to be left with x plus 2, because as I went backwards, x times x is x squared, x times 2 is 2x. Then I'm going to factor out just the second two terms. Well, 5x and 10 both have a 5 in common, so there's an addition sign there. Multiply by, well, 5 times what is 5x? That's x. 5 times what is 10? Well, that's a plus 2. Okay? If I have done this right, and this is a key point in the process, I'm going to put a star here. You know you're at a good point if you see that this term is the same as this term. So as we factored out before, it's a common term, so we can pull that out in front. Okay, and then I'm going to see, all right, x plus 2 got factored out. X plus 2 times what is this? Well, That's times an x from there. X plus 2 times what is this term? Okay, well, I have a plus 5 there. And notice, there is our factors that we started out with. Okay, so let's look at an example here. Okay, so example 1. I identify my A equal to 1, my B is equal to negative 7, and my C is equal to 12. So as I construct my diamond, it's just an organizational tour. I do A times C is 12. B is negative 7. What two numbers, when multiplied together, is 12, and they add to 7? Well, if this one's positive and this one's negative, that tells me they both have to be negative, because if they're adding to negative 7, then one of them must be negative. But if they're multiplying to something to be positive, well, that tells me they both have to be negative. So I see that negative 3 times negative 4, thinking about my factors of 12, that will add to 7. So, or negative 7, so that's negative 3 and 4. So therefore, I'm going to use those two numbers just to rewrite this expression. I'm not changing it, I'm just rewriting it in such a way that will help me break it down into its factors. So minus 3x minus 4x plus 12. Okay, notice I'm just splitting this term. Those are equivalent. Okay, from there I'm going to look at what can factor from my first two terms. Well, x times x minus 3. And then from the second piece, anytime I have a negative, I'm going to factor that out as well. So negative 4. And this is going to be x minus 3. Again, by inspection, I know that this is the same as that. So I'm good at that point, and I've done something right. And now I can factor the x minus 3 out of these two terms. And when that's factored out, I'm left with an x here and a minus 4 here. And I have gotten my factorization. Okay, you can always check your answer by double distributing and making sure that it's equal to what you started with. Okay, so example 2, same thing. So my A times my C is going to be negative 15, and my B is negative 2. Okay, so being that this product is negative, I know that one's negative, one's positive, because that's negative. So when I think of the products of 15 that can get me to 2 from addition or subtraction, I think of 5 and 3. So one of them has to be negative to get to negative 15, but because they add to negative 2, I know the larger one must be negative. Okay, so then now with that information, using my diamond, I'm going to rewrite this term, x squared minus 5x plus 3x minus 15. Notice this statement is equivalent to that. So from here, I'm going to factor out from my first two terms an x. I get left with x minus 5. And then from these two terms, I'm going to factor out a plus 3. And I'm left with an x minus 5. Check to see if I'm doing things right at this point. That's the same as that. I'm on to something. X minus 5 I factor out. And I'm left with an x plus 3. Okay. Again, I can check my work if I want to by double distributing that back out. All right, let's see what else we have here. Example 3. Okay. So these are slightly different. So factorize first by removing a common factor. So sometimes we're going to notice that there's common factors. So 3, 6, and 72 all have a factor of 3 that can come out. So I factor that 3 out first, then I'm left with x squared plus 2x minus 24. Okay, so now at this point, I can't factor anything out of this quadratic, so now I'm going to use my a times c method to factor that. So here I have a 1, right? So 1a times c is negative 24, and my b value is 2. So my a times c is negative, so I know I have to deal with a negative and a positive. And they have to be 2 away because their difference is 2. So I'm going to have a 6 and a 4. Those multiply to 24. But they need to multiply to negative 24. So this one has to be negative because it has to add to a positive 2. Okay, so I'm just going to rewrite this term. So I get x squared plus 6x minus 4x minus 24. Okay, just kind of letting that 3 hang out to the side there. So then again, I'm going to factor out an x from the first two terms, and I'm left with an x plus 6. Look here, I'm going to factor out a negative 4, and I'm left with an x plus 6. There. Then from here, I like it because it's x plus 6 here, and I factor that out. So I get an x plus 6, and I had to multiply it to x to get that, and to get this I have to have a minus 4 there. So there are my factors for example 3. Okay, example 4. So notice we have a system established. So using a system, it's nice to put it into something familiar. So for example 4 here, what I'm noticing is that my x squared term is not first. So if I rewrite that so that is first, I'm here. Okay. Anytime we have a negative x squared term, we're always going to want to make it positive to make sure our system is going to work. I'm using a problem-solving strategy of making the problem easier. So how can I get this to be positive? Well, I can factor out a negative 1 from that term, and then I'm left with an x squared minus 4x minus 77, right? I'm just changing the sign because I know if I distributed this back through to these terms, I would be back to here. So I'm changing the signs on all of them by factoring out that negative 1. So now this looks like something I've seen before. Okay, I have values that my x value is positive, so then I'm going to go ahead and do the same strategy. Okay, so I'm going to do a times c, so that's negative 77, and then my b value is negative 4. So what two things that multiply to 77 and add to 4 is going to be 11 and 7. To be negative, I need a negative 11 and a positive 7. So I'm going to rewrite this here. Okay, now that I've rewritten the terms, look at my first two terms, factor out what I can. Factor out what I can here. What I recognize is good, that this is the same as this, so I factor that out. And then I have x plus 7. And now that is fully factorized. Okay. Let's look at example 5 here. So now we're going to have an a value that's something other than 1 or negative 1. 3 cannot be factored out from 17 or 10. So I can't get a common factor. So I'm still going to do my diamond method. So remember, it's a times c and b. So 3 times 10 is 30. B is 17. Okay, so what two numbers can multiply to 30 and add to 17? We got 15 and 2. So same process as before. 3x squared plus 15x plus 2x plus 10. So notice these two values are the same as that. So I'm not changing what these are equaling, I'm just rewriting them conveniently so now I can factor them. So again, first two terms, what do they have in common? I can get a 3 and an x factored out of that. What's left over? An x plus 5. Okay, now my second two terms, 2x plus 10. Well, I can factor out a plus 2 and I get x plus 5 left. Like I said before, I'm at a good place because that is equal to that. So I factor that out, an x plus 5. What am I left with? 3x plus 2. Okay, let's look at our final example here. Example 6. Same process. A times C. My B. So what multiplies to 60 and adds to 11? I'm going to get a 6 and a 5. Okay, one of them must be negative. And, well, if one of them's negative, I'm not going to get to negative 11. So I'm going to have to try some other ones there. So other factors of 60, what about 15 and 4? So 15 and 4. So if 15 is negative, 4 is positive. They multiply to be negative 60, add to negative 11. There, I got them. Okay, so rewrite that middle term. Making sure that this piece is still equal to that. Now go through my algorithm. What can be factored out of my first two terms? Well, a 3 and an x. So I'm left with a 2x minus 5. And then of my second two terms, I can factor out a 2. And I get a 2x minus 5 here. I know this is good because this is equal to that. And I factor that out. 2x minus 5 times the quantity of 3x plus 2. And I'm done. So that is the factorization of that quadratic.